So today we're going to talk about polynomial and rational inequalities. Basically, this kind of covers the section 3.5 that we skipped over for a little bit because technically parabolas are also polynomials, so they could fit into this and we would do it the exact same way. So for us, we're going to focus on polynomials and rational inequalities and the sign chart. So I really like using the sign chart because in calculus, we'll use it so often for determining local mins and maxes, increasing, decreasing, concavity, all kinds of stuff in calculus can be determined by a sign chart. So we basically have to know where to look. So the main thing you want to do is always find your x-intercepts. Now, the reason that's so important is because this problem says greater than 0. And greater than 0 is basically a fancy way of saying when is the graph positive. Now, they didn't say when is the graph positive. They said when is x cubed minus 2x squared plus 3x greater than 0. Well, that basically means look at the graph and see when it's positive. But I don't even want to have to graph it. Now, we do have a graphing calculator, so I will show you using your calculator how it can also be done. But I just want to think of it as when is this graph positive and when is this graph negative. So what we're going to do first is we're going to find our x-intercept. So that means you have to factor. We're left with x squared minus 2x minus 3 greater than 0. You know what, I'm going to find x-intercept, so I'm just going to say equals to 0. And then this is going to be x minus 3, x plus 1 equals 0. So then we have x equals 0, x equals 3, and x equals negative 1. So then what I'm going to do is I'm going to take and I'm going to draw my number line. And I'm going to put negative 1, 0, and 3. And what I'm going to do now is I'm going to write a sign chart of when this is positive and when this is negative. So this is my function f of x, right? Or x cubed minus 2x squared minus 3x. And I'm going to plug in numbers in these intervals. So you guys understand that right here is an interval, right here is an interval, right here is an interval, and right here is an interval. So in all 4 of those places, I'm going to pick a number in between there. And the reason interval notation is so nice and the reason working with intervals is so nice is that if one of them works in the interval, in this technique, all of them are going to work. So what's a good number to the left of negative 1? I'm going to say let's try f of negative 2, right? That would be to the left of negative 1. That's in here somewhere, right? So we're checking to see what's going on in there. So now when I plug a negative 2 into this, right, into here, it's easier to work with it. You could plug it into here as well, but it's just a little bit harder to work with. So when I plug a negative 2 into there, I get negative 2 with a negative and a negative. So a negative, and a negative is a negative. So I just do this little sign chart like that, okay? Now we need to pick a number in between there. So I'm going to say f of negative 0.5, something in between negative 1 and 0. So I'm going to go back here. And I'm going to do it again. So this is a negative, this will still be a negative, and this will be a positive. So what's a negative times a positive? That is a positive. Okay, now I'm going to do f of, let's do f of 1 just because it's the easiest number to plug in. So this will be a positive, negative, positive. So then we're back to negative again. And then now let's do f of 4, okay? A number right here to the right of 3. So this is positive, positive, positive. So this is positive, okay? So now the question wants to know when is this greater than 0? So I only care about the positives. So that means my solution is negative 1 to 0 union 3 to infinity. And that's all you do. That's how you do this entire section, okay? Now we could do all kinds of other stuff. We could take this and graph it in our calculator, and we could do x cubed minus 2x squared minus 3x, and we could graph that. And we're going to see something like this. We're going to see it do one of these. Right, and it's going to do that. And now look, from here to here, that is under the x-axis, right? That's under the x-axis. So that would be negative, and that's what our sign chart says. Then if we go from here to here, that's above the x-axis. Well, guess what? That's plus. That's what our sign chart says. Then if we go from here to here, all of these values are below the x-axis, but that's why we have negatives on our sign chart. And then if we go from here to here, all of those values are above the x-axis. That's why we have pluses on our sign chart. So the sign chart already tells us what the graph is doing. We don't know quite how high it goes on the the peaks and the valleys, but we kind of have a general idea of what's going to happen. So this is something else that can help us understand the way a graph works. Okay. So now let's look at another problem. Let's look at x to the fourth less than 25x squared. So in general, you guys, what I'd like you to do is usually set the right hand side to 0. Just in general, it doesn't have to be that way. There's multiple ways you could look at this. You could look at when is the fourth power polynomial less than the squared polynomial, and then you could just find those parts of the graph. That also works. That's one way to look at it. I really want to focus on the sign chart though, so we're going to do x to the fourth minus 25x squared is less than 0. So now we factor this, and again, the key is always to find the x-intercept, so that means we have to factor. So it's x squared times x squared minus 25 equals 0. So x squared times x minus 5, x plus 5, so equals 0. So x equals 0, x equals 5, and x equals negative 5. Now something to note is x squared has a multiplicity of 2. X equals 0, I mean, has a multiplicity of 2. So that means it's going to bounce or touch the number line and then go back up. But again, we're more concerned with the number line and the sign chart, but this will maybe help you make sense of why it's doing this. Okay, so what we're going to do is we're going to take negative 5, we're going to take 0, and we're going to take 5, okay? And we're going to plug those in. So now we're going to once again pick f of negative 6. We're going to pick numbers to the left. Now we're going to pick a number in the middle. And now we're going to pick a number to the right of 0. And then now we're going to pick a number to the left of that, or I'm sorry, to the right of 5. So let's see what we get. So when I plug negative 6 into here, right, I have a positive, a negative, and a negative. So we have a negative and a negative, and then a positive, so that would be a positive. Okay, now we're going to plug in negative 1. So right here will be a positive, negative, positive. So a positive, negative, positive is a negative. Okay, now we're going to plug in 1. All right, so now we're going to plug in 1, and we get positive, negative, positive. So it stays negative. And that's what I mean by it bounced. It bounced off of 0 and went back down. So it probably was doing something like this, right? We're probably doing something like this, and then it did this, but then it bounced and came back down, and then more than likely it's going to do one of those. Okay, and again, I'm not sure what this looks like, but that's just my feeling. So now we plug 6 in, and we get positive, positive, positive. So this is positive, right? And now I would graph it on my calculator just to see if my assumption was correct. And we have x to the fourth minus 25x squared. Yep, that's what it does. So it does something like this. It goes like this, and then it comes up here, and then it bounces back down, and then it comes up here. So it looks like a W kind of, okay, or something like that. So that's basically what the function is going to look like. And now I see why we have negative twice, is because in both of these locations, it's below the x-axis. So then when we go to write our answer, now here's the catch. The solution says less than 0. So we only care when it's negative. So that would be from negative 5 to 0, union 0 to 5. Now some people want to know, why don't you just do negative 5 to 5? Because at 0, so when you're actually right here, let me do this. When you're actually right there, it bounces off the x-axis. So for a moment, it's not negative. It actually touches the x-axis. So at that moment in time, it is not equal to 0. It is less than 0, right? I'm sorry, for that moment in time, it is equal to 0, but it is not less than 0, okay? So if you actually make it to 0 and touch it, you are no longer negative. So that's why we needed to put parentheses and make it a union, okay? Now, let's look at a little bit different problem. Let's look at one like this. So these are rational functions, so x minus 6 over x plus 5, okay? All right, and we're going to set this guy less than 0, okay? So the common mistake would be to do this. Some people like to do x plus 5 over 1 and x plus 5 over 1, over 1 and cancel, and then you just have x minus 6 less than 0, and you think everything's great. Well, you will actually usually lose an answer in this. Something will go wrong for you, so let's not do that. The normal way to do this is you set the numerator and the denominator equal to 0, okay? So what we're going to do is we're going to say x minus 6 equals 0. We're going to find when that happens, and we're going to say x plus 5 equals 0. So this is your go-to move with rational functions. You do both, the numerator and the denominator. So we have x equals 6, and we have x equals negative 5, okay? So once again, what I'm going to do is I'm going to take my number line, and I'm going to come over here, and I'm going to do negative 5, and I'm going to do 6. And then I'm just going to say f of negative 6, f of 0, and f of 8. Notice I'm picking numbers that are in each of the intervals. And the beauty of intervals is if one of them works, they all work. If one of them breaks in that interval, they all break. So you only have to test one. Okay? So now, when I do negative 6 into here, now we're going to plug that in. That's going to be negative 12 over negative 1. But a negative over a negative is a positive. And I need to see this in your work when if and when we take an exam on this. Now let's plug in 0. Well, that'll be negative 6 over 5. So that's negative, negative, negative. And then when we plug 8 in, that's a positive over a positive. So that'll be positive. Do you guys notice that I don't even care? I'm not even concerned with what number it is. I only care if it's a positive number or a negative number. I don't care if it was 8/5 or 17/3 or 7. I don't care. All I care about is positive or negative, because the problem only cares about less than 0 or greater than 0. So in our case, we only care about less than 0, so that would be from negative 5 to 6. And we're done. That's the solution, okay? Now, if you want to graph this, you take out your calculator and you graph parentheses x minus 6, close parentheses, divided by parentheses x plus 5. And now I graph it, and I get something pretty crazy. So let's see here. There is a line here that goes like this, and then there's another line here that goes like this, and then it seems to do one of these. Now it looks like there's an asymptote right here maybe, but why is that? Well, remember we said when the powers are the same in the numerator and the denominator, or the degrees are the same, there's going to be a horizontal asymptote at the coefficients divided, or the ratio of the coefficients, which in this case would be 1. So this, I would assume, is y equals 1 right there. Okay, then right here, that is an x-intercept, because when you plug 6 in, you get 6 over, or 0 over 11, which is 0, so that's your x-intercept. That's why it crosses right there. And then here, more than likely, there is a vertical asymptote right here. So this is why the graph is behaving this way. So you could choose to do it graphically, but I'm going to tell you guys for this class, I would prefer, or I may even ask you to show your sign chart for full credit. So please get used to using the sign chart. It is something we will work on in Calc 1. So here's this. So I'm just going to erase the graph for the most part. Okay. I know if I erase that, yeah, I knew that was going to happen. And then we got that, and then we got that. Okay, so yeah, graphically, graphically is okay, but I really like the sign chart. So we're at -5, 6. Okay, So let me have you guys, these are normally the harder ones, so let me have you guys try one of these. Pause the video after I give it to you. So solve this rational inequality. Okay, so take a minute and set that problem up. Okay, so you guys hopefully unpause the video, and you had your zeros of the numerator to be -5 and 3, and then x equals 1. So I'm going to come over here, I'm going to draw my number line, and I'm going to use -5, 1, and 3. And I'm just going to pick some numbers to the left or to the right, right? So I'm going to say f of -6, f of 0, f of 2, and f of 5. It's always good when you don't have to use fractions, but you could use them if you need them. So I'm going to plug -6 into here, okay? And that's going to see a negative and a negative and a negative. So that's 3 negatives, so that's going to stay negative. Now I'm going to plug 0 in. That's going to be a positive times a negative, which is a negative, divided by -1, which was positive. Now we're going to plug a 2 in. That's a negative times a positive, which would be negative, divided by a positive, which would stay negative. Now we're going to plug 5 in. We get positive, positive, positive. So positive divided by a positive is positive. And there we go. So we have it. Now all our job is to find out when the graph is greater than or equal to 0. Well, when is the graph positive? It would be from -5 to 1, union 3 to infinity. But this time, you see this right here? This is or equal to. So that means we can use brackets now. And then you never use bracket on infinity. However, I made a little silly mistake. I'm now saying that 1 is okay. 1 is an acceptable answer that will make it equal to 0. However, look at the domain. The domain is x such that x cannot equal, +1, right? That's my domain. Okay, so that means I have to get rid of that. Even though I wanted to use a bracket, I have to use parentheses. Now 3 is acceptable and -5 are acceptable because they are in the numerator. But 1, x -1 is in the denominator, so I have to use a parenthesis on that, even though the problem told me to use a bracket. Okay, so these are good, solid test questions. Let me show you another one. (4x -1 all over x plus 5 less than or equal to 3). So there's a couple ways to do this. I think the best way is the slower way, and it's the safer way. So again, you want it with a 0 on the right-hand side, right? So I'm going to write 4x -1 over x plus 5, and that's going to be -3 is less than or equal to 0. So now this has a 1, so I need to give it an x plus 5 and an x plus 5, so they have the same denominator, because I want one rational function. I just want one big fraction bar. So this is going to become 4x -1 over x plus 5 minus 3 times x plus 5 all over x plus 5, and that's going to be less than or equal to 0. Okay, so let me come over here. Now when we clean this up, this will be 4x minus 3x, so that'll be x, and that'll be -1 minus 15, so that'll be minus 16, I believe. And then we're going to divide that by x plus 5. Okay, and then we're going to say that this is all less than or equal to 0. So now we're going to draw our number line. And we now know that it is -5 and 16, right? Because we took this and we took this and we set each one of those equal to 0. And now let's do our sign chart. So let's do f of -10. Let's do f of 0, and let's do f of 20. I like to use nice, easy numbers as long as they're in the intervals. So when I put -10 in the numerator, I'm going to get negative over negative, which is positive. Then I'm going to put 0 in there, and I'm going to get -16 over 5, which is a negative. Then I'm going to put 20 in there, and I'm going to get a positive. So then I only care about when this is less than or equal to 0. So this would be -5 to 16, brackets this time. But once again, we notice we can't put a bracket on -5, so we do parentheses -5. okay? And that is how you do rational inequalities, okay? Now, what I wanted to show you also, and this is just like a little follow-up from 3.5, so I might put a few 3.5 questions in here, is what if they gave you x squared minus 3x, let's do 2x, minus 15 is greater than or equal to 0, okay? Well, we know how to factor this. This would be x minus 5, x plus 3, oops, equals 0. So then x equals 5 and x equals negative 3, correct? Because negative 5, negative 15, let me make sure I didn't go too quick. My brain's getting a little tired today. So it'd be negative 5x plus 3x would be negative 2. Nope, that's it. So then I'm going to come over here and I'm going to draw my number line. I'm going to put a negative 3. I'm going to put a 5 here, okay? Now the thing is I know that this is an upward facing parabola, okay? And I don't even need that though. I can just use my sign chart to answer this question. So I'm going to do f of negative 5, I'm going to do f of 0, and I'm going to do f of 6. So when I plug negative 5 into here, I get negative 10 and negative 2. That's a negative and a negative is a positive. Then when I plug 0 into there, I'm going to get a negative and a positive is a negative. And then when I plug 6, I get a positive times a positive, which is a positive. So then I know that this graph is greater than or equal to 0 from negative infinity. Oops, let me write it further down. From negative infinity to negative 3, union 5 to infinity. And again, all I'm doing, you guys, is I'm looking at where is it positive. Oops, let me undo that. Let me fix this real quick. Okay, so where was it positive? To the left of negative 3 and to the right of 5. So I did my job, right? Or where was it positive or equal to 0? Now, if I wanted to graph this, I know that it's a parabola that's upward facing, so it has to look like this. I know that because I just know how parabolas behave, right? So this is a parabola. I have my axis of symmetry right down the middle. Now here's the thing. Where is this parabola above the x-axis? Well, that would be right here, and that would be right here. In both those locations, it is above the x-axis, but that's the same thing that my sign chart told me. It told me the exact same thing. So this is a 3.5 problem, but you can use what we learned in chapter 4 to do it. So I'm probably going to throw a couple 3.5 questions in the 4.6 homework, but not too many. Because a polynomial, a parabola is a polynomial, so whatever works on polynomials should work on parabolas, okay? All right, you guys, I don't want to make this video too long. This is kind of just getting us to where we want to be. And this is a pretty straightforward section in terms of not a lot of concept per se, a lot of understanding of intervals and sign charts, okay? And again, you also have to be able to factor very well. If the problems are ever too hard to factor, then you probably have to use some other technique. Like the worst of all the problems would be that you would have to use what you used in 4.3 and 4.2, where you had to do long division and then you had to write it in factored form, and then that would tell you the zeros. You know, so hopefully we don't run into too many of those. But yeah, that's something you might see like one in the homework or something like that. But that's going to do it for this video, guys. Thanks for watching.